When you need a machine to count, but you don't have a computer, just build yourself one of these. This is a stepper unit, one of 6 inside this pinball machine. In a previous video, we looked at the targets on its playfield, how the machine totals and shows you your score, and how, with a few relays and a wacky contraption called the score motor, the machine can perform automated sequences. Sequences such as awarding 5,000 points with a single switch hit, or even scanning through the 5-letter targets and awarding points based on how many you hit earlier in the game. If you haven't seen that video, I would highly recommend watching it first. I've summoned a clicky thing for your convenience. A lot of what I cover here builds from that video, and since we've got a lot ahead of us still, I promise you that I will be striving with fervent commitment to restrain my various recapitulations to as diminutive a quantity and length as I can possibly muster, in the perhaps optimistic hope that my restraint in this matter will result in a more economical expenditure of that most precious and finite resource we call time. We'll begin at the start. Pinball machines are an awful lot of fun, but we mustn't forget that the primary reason for their existence isn't fun. It's money, money, money. This machine's prime directive is to relocate some quarters from your pockets to the cash box locked inside. And to make that more likely, it doesn't work unless you put money in it. When the Game Over indicator on the back glass is illuminated, the flippers are disabled, the ball gets a break and chills in the out hole, and the only way to start a game and play it is by feeding it a quarter. And would you believe it's literally the quarter that starts the game? 'Cause it is. This leaf switch here is what will kick the machine out of Game Over mode and start the reset sequence. And it's actuated by the movement of a small tripwire that quarters fall onto if they're accepted by the coin mechanism. Coins that are rejected by the coin mech will fall forward of this point and end up behind the coin return flap so you can get them back. Now, I'm not going to get into the actual coin mechanisms here, but I will add 2 bits of trivia. Oh, right. Firstly, these coin mechs are modular components that can be swapped without tools. Partly, that's for maintenance considerations. These are fiddly things which need occasional cleaning, adjustment, and possibly replacement. But they can also be swapped for different denominations, and when this particular machine left the factory, one of these coin mechanisms probably accepted dimes. You'd get 1 play for 10 cents, or 3 plays for a quarter, a volume discount. There are several options actually as far as how you want to configure the plays per coin type, and this coin door can even accommodate a 3rd coin mech in the middle position. Right now it's simply blanked off. At some point in this machine's life, its operator swapped the dime acceptor for a 2nd quarter acceptor, changed the faceplate to reflect that, and configured the machine for 1 coin, 1 play. The other interesting thing here is this, the coin lockout magnet. This electromagnet must be energized in order for the machine to take your coins. If it's not, spring tension causes small wire loops to poke into the validation path of the coin mechanisms, which causes them to return all coins, even if they're deemed good. The purpose of this is twofold. 1, if the machine is switched off, it can't possibly start a game, so you don't want it taking people's money. And secondly, even when the machine is on, it can only process one thing at a time. If, say, you wanted to add a 2nd player, which you do by feeding it a 2nd quarter, but you did that while it was in the middle of the reset sequence, the coin hitting that leaf switch wouldn't actually do anything. Thus the machine would just steal your quarter, and you'd be mad. To reduce the risk of that happening, the coin lockout magnet gets its power through a switch on the index stack in the score motor. It will thus only be energized when the score motor is stopped and idle, which is the machine's only state in which it can correctly process that you've inserted a coin. Technically, someone could shove a quarter in at just the right moment and still have it get eaten, but the odds are very slim. Moving on though, between games the machine stands by in Game Over mode, where nothing works and this light is on. And what puts it in Game Over mode, you ask? Why, the Game Over relay, which lives here in the main cabinet. This is effectively the main on-off switch for the game's automated functions. This switch within the relay breaks the return path to the transformer for an awful lot of stuff, including the flippers, the bumpers, all of the targets and their respective relays. Basically, the whole game stops working when the game over relay is tripped. Because, game over. Now, you may notice that this relay is not like any of the others we've seen. It has two electromagnets, because this is a latching relay. Not, it should be noted, a relay which latches by powering itself through some other switch somewhere else in the machine, but one that mechanically latches into one of two stable states. This coil, the trip coil, will shut off the game once it's fired. The other coil is the latch coil, which turns on the game once it's fired. Also, quick note, this is the Williams logo, not the Motorola logo. They are awfully darn similar, but Williams made these relays in-house. So did Bally and Gottlieb. When you make thousands of pinball machines per month and each machine has dozens of relays, it definitely pays to roll your own. See, they're rolls of wires rolled around a hollow coil. Anyway, moving on. Given what we've just learned about the game over relay and how one coil turns off the machine and the other coil turns it on, what do you suppose the coin switches in the coin door send power to start the game? That's right, the coin relay. Or maybe the 10-cent relay, or even the 25-cent relay. Okay, I'm skipping over all the stuff you can do for different coin types and plays per coin. It involves the score motor and adjustment jacks, and is a layer of complexity we just don't need right now, but it is in fact the coin relay that actually gets the ball rolling. And folks, explaining the next steps here is going to take a while. If you haven't already gathered, a lot of stuff needs to happen when you insert a coin to play this game. The machine has various mechanisms throughout that may be in any number of configurations depending on how the last game went, including, of course, the score readouts. But we need them all to return to a known starting point before we can begin a new game. We are about to embark on a dissection of this machine's reset sequence. And I regret to inform you that calling it a single sequence is quite the oversimplification. So strap in. Up here on the schematic is the coin relay's coil. It becomes energized by the coin switches, but as we've seen before, a switch within the relay provides a power bypass so the relay will lock on and stay energized even after the original signal from the coin switch is lost. The coin relay is also one of the many things that will start the score motor turning. And just like the 5,000 point relay we looked at in the last video, its power bypass goes through switch 5B in the score motor. So here we have another example of a relay that locks on, starts the score motor, makes some stuff happen as the score motor turns, and releases just before the score motor returns to the parked position. This unassuming little switch in the coin relay is what actually resets and starts the game. Looking at the schematic, you'll notice that the circuit branches off at this point and meets another two switches. This switch here is in the score motor on switch stack 1, and since it's normally open, power doesn't make it through just yet. The score motor has to move forward a bit to close this switch. But power will make it through this switch in the game over relay. Now, you might very well be saying to me, but that switch is drawn as open, dingus. And you'd be right. But this particular switch is a confusing little bugger. Every switch in the schematic is depicted as either normally open or normally closed, which is obvious enough for nearly everything in the game. Normal is defined by a switch's resting position. So in the case of relays, that means their position when the relay isn't energized. But the game over relay doesn't have a single resting position, it has two resting positions. Its two separate coils flip it back and forth between one and the other. So, for the purposes of drawing that relay's switches in the schematic, the drafters had to just pick one. And, unfortunately for us, looking at this specific part of the game's logic and sequencing, they decided to depict the game over relay in its latched position, meaning the game is on and in play. For most of the schematic, that decision makes much more sense. But since I'm going through what happens to actually turn the game on, prior to inserting a coin, the game over relay is in fact tripped, and thus every one of its switches is in the opposite position from how it's drawn. Therefore, at the moment you insert a quarter and the coin relay energizes, power does get sent up through here to the reset relay coil, and so the reset relay pulls in. And just in case you're not confused enough already, you should know that the reset relay isn't actually responsible for resetting the game. It only resets the scores. I will explain that in a moment, but for now, we're just going to ignore that and focus on the next thing that's about to occur. Since the coin relay also starts the score motor turning, in just a moment switch 1B will be pushed closed by the movement of cam 1, and a pulse of power will get sent through to all this stuff. Now you'll notice that the reset relay is also involved here with these two switches. Why? Well, there's some complicated interlocking going on here since this is a multiplayer game. For now, let's pretend we're just starting a new single-player game. Since the reset relay has been pulled in to reset the scores, this make-break switch will send power down this way and we'll skip the coin unit step-up coil. This switch is also closed, so the upshot is that everything shown here except the coin unit step-up coil will get actuated by the score motor through the coin relay. So now, what are these everythings? First, we have the total play meter. That's this odometer looking thing which counts how many times the game has been played, which is useful to know for lots of reasons, including gauging the need for servicing and auditing the machine's cache intake. Then remember, we're skipping the coin unit step-up coil. Instead, we hit the coin unit reset coil. Then there's the game over relay latch coil, which remember actually turns on the game. And we also send power to reset the ball count unit and the player unit. What are all those units? Stepper units. That's what you saw in the thumbnail and I mentioned in the beginning. These are the devices that allow the machine to count and/or change its behavior based on their physical positions. Stepper units come in three flavors: continuously stepping, step up, step down, and step up reset. Now, they might look pretty complicated, but in reality, they're a pretty simple idea. In fact, score reels are technically a kind of continuously stepping stepper unit. A solenoid advances a ratcheting mechanism, which moves the drum forward by 36 degrees. They are continuously stepping because they can only move in one direction and don't have a defined endpoint. But you don't have to move a plastic drum with numbers printed on it. You could also move a series of wipers across a circuit board which will bridge contact patches together. And you can change the machine's behavior based on what you wire to that circuit board. If you add a second solenoid to this mechanism, which can step it in reverse, then you've got a step-up, step-down stepper unit. This machine has two of those, which we'll be looking at later. But if the second solenoid resets the stepper to its starting position with a single actuation, you've got a step-up reset stepper unit. The ball count unit, coin unit, and player unit are all reset with a single pulse to their reset solenoids. So when the score motor and coin relay send a pulse of power to their reset coils, they all return to their starting positions in one fell swoop. And that's what the coin relay just did. In addition to switching the game on by pulsing the game over relay latch coil, it got all of the game's critical stepper units reset to a known beginning state. The ball count unit was reset to ball 1, the player unit was reset to player 1, and the coin unit was reset to single player. Don't worry about that right now. But also, don't forget that we have to return 20 other stepper units back to a known state. The score reels. I'm sorry we're moving back and forth so much, but what I've just described all takes place in a fraction of a second. It's been a challenge to decide how best to go about this. Remember that the coin relay also sent power to the reset relay up here. But you'll notice that there is in fact more than one reset relay. There are 4, helpfully numbered 1, 2, 3, and reset relay. For your sake, I'm going to call those numbered fellas the bump relays, 1, 2, and 3. Trust me, that makes way more sense. The main reset relay, like so many others in the machine, will lock on through a switch within itself, but this time its interlocking switch can get power from 3 separate sources. Did I say 3? I meant 22. See, the primary thing the reset relay is actually doing is sending pulses through the score motor to those bump relays. When the reset relay is energized, power flows through impulse switch D, which will send pulses to bump relays 1 and 2, and a second branch flows through impulse switch A to pulse bump relay 3. And this is what that looks like. Those 3 relays are clacking away in the back box 5 actuations at a time. Of course, I've rigged this to keep on clacking non-stop. Typically they only do this 10 times and then the game is reset. What is it those bump relays do? The switches within these relays send pulses of power to all of the score reels to repeatedly bump them, or advance their position. And each one of the score reels will stop automatically when it reaches 0. If you're wondering how that could happen, remember the 9th position switch we saw in the last video? Well, I strategically ignored the other switches in that stack until right now because those are 0 position switches. The little pivoting arm that pushes the switch stack up at the 9 position swings the other way at the 0 position and opens these 2 switches. One of the switches connects the solenoid in the score reel to its respective bump relay switch. When it's showing any number other than 0, that switch is closed, so the score reel solenoid will repeatedly receive a pulse of power during the reset and thus keep moving forward. But once it gets to 0, that switch opens, so the pulses no longer make it through to the score reel solenoid, and it stops moving. The other switch in the switch stack is part of the interlock circuit of the reset relay. And every single one of those in the machine is wired in parallel, so that if any score reel should be on a number other than 0, the reset relay will remain energized, and thus it will keep firing the bump relays to get them to 0. That means there are actually 22 different switches that can provide power to the reset relay. This switch in the index stack, this switch in the bonus relay, and the 20 switches in all of the score reels. Oh, and look at that! There's a mistake in the schematic. Somebody forgot how many score reels they were putting in this machine and said there were only 16 switches. How embarrassing. It's a good thing schematics don't have comment sections or they'd never hear the end of it. Jokes aside, that's understandable. It's actually quite odd that this game uses 5 score reels per player. Most of its contemporaries only used 4, and I have a hunch that since this machine was built during the development of the new solid-state control systems, which would use digital display technologies, Williams realized that all of the score reel parts they had in their inventory were about to become obsolete. So they might as well start using 5 per player to try and get rid of them. Aztec wasn't alone in this. Several other Williams games from 1976, such as Grand Prix and Space Mission, also used 20 score reels per game. But as far as I can tell, all games released in 1975 stuck with 4 per player, 16 total. So I bet that little slip-up on the schematic was simply out of habit. Anyway, in action, the resetting of the scores looks like this. Every score reel gets bumped until it shows 0. Since it should only take 9 bumps at most to reach 0, 2 cycles of the score motor, with 5 bumps each, is enough to reset all the scores. Once they're all on 0, all of their 0 position switches are open, so the reset relay will de-energize. If we look at the 3 bump relays during this sequence, you'll see tremendous amounts of arcing going on when the machine resets, especially after a 4-player game where nearly every score reel is off of 0. Now, 20 solenoids all firing at the same time is a recipe for a blown fuse, so you might have noticed that the score reels were actually moving in 2 groups. It's very subtle, but see if you can spot it. I'll slow that down. This grouping is accomplished by the impulse forward switch on the score motor. That switch, which the schematic designates impulse switch D, is positioned literally forward of the other impulse switch stack. That way, the 2 don't get actuated at the same time by the movement of the cams below. Instead, they alternate, and the number 3 bump relay fires before 1 and 2. That breaks the score reel solenoids into a group of 12 and a group of 8, much more manageable current-wise. Okay, so at this point, the game is on, the scores all show 0, and the stepper units the game needs to keep track of its program are all reset. So now what? Well, it needs to kick the ball out of the out hole and into the shooter lane so you can actually play the game. Let's look on the schematic for the out hole kicker coil so we can find out what sends power to it. Apparently it's called the ball release coil. Okay, so it's going to get power from switch 4B in the score motor, but only if this switch in the out hole relay is closed. So let's find the out hole relay then. Oh, it's right up here. Okay, so that relay's got its own switch to lock it on, of course it does, and like so many other things, that power path will eventually be broken by switch 5B in the score motor. But what gives it the initial pulse of power is the... what's all this? Why is it going through the bonus relay and the bonus unit 0 position switch? I'll tell you why. It's another utterly confusing thing. The out hole switch, that is, the switch the ball closes when it lands in the out hole, energizes the bonus relay, not the out hole relay. The out hole relay, in turn, is energized by the bonus unit's 0 position switch. For now, we're going to ignore the bonus unit. I promise this is going to make sense eventually. So, we've inserted a coin. The game and scores have reset. We're on ball 1 and player 1 is up. The bonus unit was in the 0 position, so the out hole relay did get energized, which caused the ball release coil to be fired when switch 4B of the score motor was actuated, and now the ball is finally in the shooter lane and the game can be played. But now, I'm going to put the ball back into the out hole. Watch what happens. The ball was sent back to the shooter lane after 2 cycles of the score motor, and the ball in play did not change. We're still on ball 1. I can just keep doing this forever. And the game will keep serving me the ball again and again. Why is it doing this? Well, suppose the ball release coil is getting weak, or the mechanism is gummed up in some way. It may not get the ball into the shooter lane on the first try. The designers foresaw that possibility, or more likely, older games screwed this up and they learned a lesson, so they designed an interrupt into the program which prevents it from advancing to the next ball until the ball has actually hit a target. That interrupt is in the form of a relay, would you believe it? And that relay is the ball index relay. This is the relay itself, and this is where it lives on the schematic. This relay is connected to switches in the 10, 100, and 1000 point relays. In this particular game, the ball must hit at least one target worth those point values as it enters the playfield. If it doesn't hit a 100-point rollover button, it may hit the 10-point bumpers, and if it misses both, it will absolutely go through one of the 1000-point rollover lanes. That means that technically the only relay that needs to activate the ball index relay is the 1000-point relay, but all 3 can activate it, most likely for redundancy in case one of those switches gets dirty or fails. Anyway, here's why it's important. Until this relay is energized, the game does not consider the ball to have made it to the playfield, and it will not increment the ball count if the ball ends up in the out hole. It will just keep trying to serve the ball to you over and over again. But once it does, you are free to have a ball and play the game. Since I've already gone over how all the stuff on the playfield works, we're not going to get into much at all here, except for this: advance bonus. Some of the targets advance the bonus value, shown by this arc of illuminated inserts on the playfield, which us pinball nerds call the bonus ladder. Every ball begins with 5,000 points, which will be awarded at the end of the ball, but you can increase the bonus value by hitting the targets that say advance bonus. Watch what happens when I hit the center rollover button. We hear a click, and the next light on the bonus ladder is now lit. That click, it came from, well, 2 things actually: the advance relay and the bonus unit step-up coil. The bonus unit lives on the underside of the playfield, not too far from the bonus ladder, as it turns out. You may notice that there's a pretty large crack in it. Did I do that? That's not important. This is a step-up, step-down stepper unit. One solenoid moves the wiper arms forward by 1 step, and the other moves them backward by only 1 step. This has 11 possible positions: 0, 5,000, 10,000, 15, 20, 25, 30, 35, 40, 45, and 50,000 points. The contacts and wipers here are mostly used for the indicator lights in the playfield. These bonus lights are wired to those little studs, and the wipers connect each individual light up to a power source as they move, thereby showing how many steps away from the 0 position the bonus unit's mechanism is. The player doesn't realize that's what's going on, they just know how many bonus points they're due at the end of the ball. But you know that's what's going on because I just told you. That's the critical piece of information here. How many steps is the mechanism away from 0? That in and of itself is what's totaling the points to be awarded. To explain how that works, let's say there's 15,000 points on the bonus ladder and you lose your ball. The ball's going to end up in the out hole and land on the out hole switch. When it closes, power that's coming from the score motor and traveling through this switch can finally make it through and energize the bonus relay coil. That relay will lock on through this switch here, and then, well, it's got to award 15,000 points. To find out how that happens, we need to look at the 1,000 point relay. In addition to all the stuff down here that we looked at before, there's a path through the double bonus relay and this bonus relay switch and the ball index relay to this gray and white wire up at D7. And what we find once we go up there is impulse switch C. Since that's going to send 5 pulses of power through as the score motor turns, the 1,000 point relay gets actuated 5 times, and 5,000 points are added to the score. But of course, we're not done, and indeed adding those points isn't all that happened. Watch how this sequence actually occurs. Just after the 5,000 points are awarded, we hear a clunk and the bonus ladder moves down to 10,000 points. That clunk was the bonus unit reset coil moving the stepper unit's wiper arms back 1 notch. Let's find that on the schematic so we can see why that happened. Here we are. That coil gets its power through switch 5A in the score motor. That then travels through a make-break switch in the double bonus relay before hitting the switch in the bonus relay. Because of the sequencing in the cams of the score motor, switch 5A is actuated just after the 5th pulse of the 1,000 point coil. So, as we saw, we got 5,000 points, then the bonus unit moved down to 10,000 points remaining. Now the ball is still in the out hole, and the bonus unit is still not in the 0 position. So what happens next? The same exact thing. The 1,000 point relay coil gets 5 pulses, awarding 5,000 points, and just after the 5th pulse, the bonus unit steps down, and now 5,000 points remain. Since it's still not at 0, and the ball is still in the out hole, we repeat this once more, and our 15,000 points have been awarded. However, after those last 5,000 points are awarded, the bonus unit reset coil is still going to get pulsed. Once it gets that pulse, it's going to move and end up in the 0 position. And now things change. Remember how the bonus relay was getting power? It initially came through this make-break switch marked bonus unit 0 position switch. At 0, power is redirected, disconnecting power from the bonus relay coil and instead sending power to the out hole relay coil. Also of note, the bonus relay's power bypass went through a 0 position switch in the bonus unit too. So once the bonus unit has made it to the 0 position, the bonus relay is de-energized and effectively locked out. So now, what happens next? We know the out hole relay has been energized, but without hunting through the schematic to find every out hole relay switch, how are we to know what it actually does? Well, we do know 3 things are going to happen for sure. It needs to give the ball back so ball 2 can be played. It also needs to reset any of the relays that might have been triggered in the last ball, like the Aztec relays, and let's not forget the ball index relay. And then it needs to move the ball in play from 1 to 2. Let's look at those one at a time, starting with those relays. That's actually pretty simple. Every relay which locks on through the course of a ball in play but resets when a new ball begins is wired through this normally closed switch in the out hole relay. As soon as the bonus count is finished, those relays will all release since the out-hole relay becomes energized and opens this switch. And sure enough, that's what we see. Since it also has to give the ball back, let's revisit the ball release coil. We've already looked at that before, and it is pulsed by switch 4B in the score motor through the out-hole relay, just like it was when it delivered the first ball of the game. But now, since we have played through the first ball, it has to move the ball in play from 1 to 2. That's handled by the ball count unit, which lives here in the main cabinet. It's another stepper unit, but this one only has 2 wiper arms, both of which are wired to the common ground back to the transformer. To explain what that means, this arm lights up the ball in play lights on the back glass. And there's actually voltage going through the light bulb filaments all the time. The only reason they aren't all lit right now is that the wires for each bulb are broken right here. They reach a dead end at the contact patches. The wiper arm, though, will complete the circuit once it touches the patch. The corresponding light then becomes lit depending on the position of the ball count unit's arms. Oh, and by the way, I do appreciate how Williams arranged these lights in the order 1, 4, 2, 5, 3. Since this can be set to 3-ball play, it would probably make you feel a little ripped off if the last ball shown was in the middle of this yellow box. Clever thinking. The other wiper and contact patches on this stepper? Those come into play at the very end of the game. See if you can guess what they complete a circuit to. As a refresher, this is a step-up reset stepper, and its reset coil was pulsed at the beginning of the game to return it to the ball 1 position. But now we've played ball 1, the bonus points have been awarded, and it needs to move to ball 2. So let's find the ball count unit step-up coil. That's up here, and now you're going to get a clue about how this machine handles multiplayer games. The circuit path for the ball count unit step-up coil is about as convoluted as it could be. Power goes through the out-hole relay, then the extra ball relay, then the ball index relay, then switch 1C in the score motor, then it takes one of several possible paths through the player unit and coin unit before finally hitting the coil, which moves the ball count unit up. But all we need is a single pulse, and once it's sent through, it moves to the next position. And now ball 2 is shown on the back glass, and the ball is back in the shooter lane to be played again. Everything in the game is exactly as it was in the very beginning, other than the score reels for player 1 being wherever they happen to be, depending on how well you did, and the ball count unit being in the second position, which illuminates the 2 on the back glass. You play ball 2, the first target the ball hits energizes the ball index relay, the rest of the ball goes how it goes, and when you lose the ball, the exact same sequence we just went over will happen again. The out-hole switch energizes the bonus relay, which will award 5,000 points, then step the bonus unit down. It repeats that until the bonus unit hits 0, at which point the bonus relay becomes locked out, the out-hole relay takes over, whatever relays that locked on in the prior ball are all released, and the score motor sends pulses of power to several things in sequence, including the ball count unit to move to ball 3, and the ball release coil to send it back to the shooter lane. Simple! But I've forgotten something. Every ball begins with 5,000 points on the bonus ladder already. That means the bonus unit step-up coil must be getting pulsed by the out-hole relay at some point in its sequence. And sure enough, it is, through switch 3B in the score motor. This explains why, if the ball lands in the out-hole before it hits a target on the playfield, it takes 2 cycles of the score motor for it to return the ball to you. What actually happened just there is the same exact sequence as if you had lost the ball. The out-hole switch energized the bonus relay, and it attempted to award 5,000 points. That takes 1 cycle of the score motor, and the bonus unit reset coil was pulsed at the end. Then, with the bonus unit in the 0 position, the out-hole relay took over. It's no different from any other ball drain. However, since the ball never made it onto the playfield, these open switches in the ball index relay prevented it from actually awarding those 5,000 points while the bonus relay did its thing, and from incrementing the ball count when the out-hole relay returned the ball. Pretty clever. But let's get back to where we were. We are on ball 3, and this time, let's say you score an extra ball during play. That becomes possible when all of the Aztec letter targets have been hit. And, quick note, that's affected by the game's difficulty adjustment, which we find here in the schematic. I am not going over that, but when set to conservative, as it is now, once all of the Aztec relays are energized, the center target becomes lit for an extra ball by the setup relay. That lights the when lit light and also closes this switch. If you manage to hit the center target then, a pulse of power is sent to the extra ball relay, which then locks on until the end of the ball and lights up the same player shoots again lights both in the back glass and on the playfield. How does that give you an extra ball? You may remember that one of the things in that convoluted circuit path which incremented the ball count unit was a normally closed switch in the extra ball relay. Since, once you've earned an extra ball, that switch becomes open, well, the pulse from the score motor that would increment the ball count unit after the bonus countdown simply doesn't make it through. The game will do everything it normally does at the end of a ball, including awarding the bonus and returning the ball to you to be played again, but it won't move the ball count unit. It will just stay where it was. It also doesn't send a pulse through to the player reset relay, but that's not important right now. The extra ball relay's interlock path goes through all the points relays as well as the ball index relay. So once you get an extra ball, the same player shoots again lights remain lit until the same player shoots again and the ball actually hits something. The last thing I want to touch on is what happens when you activate double bonus. You score double bonus by hitting either of these targets after hitting the Z or T targets. When both conditions are met, that will activate the double bonus relay. We've already seen the double bonus relay switches come into play a couple of times in this video, but what they actually do is quite interesting. First, of course, it lights up the double bonus when lit indicator, but it also radically changes how the bonus sequence occurs at the end of the ball. Notice that this make-break switch connects the bonus unit reset coil to impulse switch B in the score motor. That will make it rapidly fire 5 times with each score motor rotation. We also find that this make-break switch redirects power from the 1000 point relay to the 10,000 point relay. In action, this means that the awarding of your bonus points happens much more quickly when double bonus is lit. Since each spot on the bonus ladder is now worth 10,000 points rather than 5,000, only a single pulse to the 10,000 point score wheel is required per lit spot on the ladder. So the process is really quick, taking at most 2 cycles of the score motor. Of course, once the bonus unit reaches the 0 position, the bonus relay releases, the out-hole relay takes over, and the same end-of-ball sequence you've been looking at happens once again, which, by the way, will remove power to the double bonus relay coil, so too bad on your next ball. I'm about to wrap up this video because runtime, but I want to focus on the word sequence. Remember that the score motor's numbered switch stacks are actuated one at a time. In this clip, I've filmed the score motor in low light so you can see how the arcing appears to travel from left to right. All of this is happening thanks to the out-hole relay. That one relay connects 5 things to these switches and they are each actuated in order. Some of them we've already touched on, others we haven't. But the order of operations is critical here, because each action that takes place might change the next. The very first thing the out-hole relay makes happen is push a pulse through switch 1C to increment the ball count unit. And after the last ball, that is the action which shuts off the game. Since this is currently set to 3-ball play, once the ball count unit moves into the position for ball 4, the other wiper completes the circuit for the game over relay trip coil. The instant it moves to ball 4, the game shuts off. You can see that if I bridge this switch together, despite being in the game over position, ball 4 lights up on the back glass. The ball count unit is actually resting in the ball 4 position, but the 3 or 5 ball play adjustment jack has connected the game over relay trip coil to this contact patch, so as soon as the wiper touched it, boom, game over. If I had this set to 5 ball play, it wouldn't have ended the game, because in that case, the game over relay trip coil is connected to this contact patch instead. So you would get to play ball 4 and then ball 5. At the end of ball 5 though, the ball count unit would step up again, and in the quasi-6th position, the game over relay would be tripped. With the game over relay tripped, the rest of the stuff the out-hole relay normally does at the end of a ball just doesn't happen. For instance, the ball release coil doesn't get power since this switch is now open. In fact, none of the stuff below this point in the schematic will work. The game is over, so it's shut off. But there is a different thing it might do at the end, and that is give you a free game. If the number at the end of your score happens to match the number that appears in the clouds on the back glass, you'll hear a knocking sound and suddenly the number 1 will appear here, indicating there's a credit on the machine, and a new game can be played by pressing the start button. How's that work? Well, I guess we're gonna need a part 3. I know, but there's a lot to this. We're almost there though. In part 3, we'll take a look at how this number match feature works. We'll also look at the credit unit. Did you know that that's what made pinball illegal in some places? Yeah, and we'll get into that too. We'll also look at how multiplayer games work, and finally, we'll talk about the tilt switch. Get too rough with the machine and boop, you've lost that ball. Better luck next time. Speaking of next time, see you next time! In the perhaps Austin... Well, already got one. That the primary reason for their existence isn't fun. It's something weird happened. The main relay, like but you'll notice that but one that mechanically latches into 2 stable not the Motorola logo. Yeah. Okay, this is a long line. Gotta start at the bottom. They, like so many others in this machine, will lock on through a switch within itself, but this time its interlocking power path, oh crap,